You've probably heard of the Big Bang as the start of the universe as we know it because of the wildly popular TV show. But what precisely occurred before the Big Bang? Is it even important to know? The circumstances leading up to the Big Bang have long baffled scientists. In today's episode, we will talk about James Webb Space Telescope's terrifying discovery before Big Bang, which will change everything. The Big Bang theory is both straightforward and simple to misunderstand. Nobel Prize winner and James Webb Space Telescope senior project scientist Dr. John Mather responds to some frequently asked questions about the Big Bang and JWST's contribution to our understanding of the universe's early history. I've heard that the James Webb Space Telescope will provide new levels of historical perspective. What will JWST look at? Despite the fact that JWST will see further back than Hubble, COBE, WMAP and Planck all saw farther back than JWST. JWST was built to observe a time of the universe's history that has not yet been observed, not the universe's origins. We are particularly interested in the first items that emerged as the cosmos began to cool following the Big Bang. The time period for COBE, WMAP and Planck were designed is maybe hundreds of millions of years later. We believe the minuscule temperature ripples they noticed were the germs of galaxies. We don't know precisely when or how the universe created the first stars and galaxies. To assist in addressing this, we are constructing JWST. Why is it so hard for Hubble to watch the first stars and galaxies form? Looking very far away is the only way to view back in time to when these items were formed. Hubble isn't big enough or cold enough to be able to detect the weak heat signals coming from these far-off objects. Please remember to hit the bell icon and subscribe buttons in order to be notified when we upload a new video. At the conclusion of this clip, we will reveal the discovery. For the thousands of scientists, engineers, managers and support staff who have worked so hard to get the JWST to this point, the launch will be both thrilling and terrifying. They can count on my anxiety as the head of the Space Telescope Science Institute Council, which will oversee the JWST Operations Center after the launch. At the time of this writing, Europe's Ariane 5 rocket in French Guiana has been loaded with a $10 billion telescope and is ready to launch it into orbit. After more than 3 decades of operation, the Hubble Space Telescope has given us breathtaking views of the cosmos and dozens of scientific discoveries. For this reason, we hope and expect it to last for many more years compared to the ground-based telescopes. A replacement for Hubble has been proposed for the enigmatic early universe JWST, but I like to think of it as a follow-up mission to Hubble Space Telescope. The Hubble Space Telescope's 2.4-meter diameter mirror is smaller, which reduces its sensitivity and ability to see the faintest objects. Hubble can access infrared light, but it cannot reach the earliest stars and galaxies, which Hubble cannot see. On the other hand, JWST will be able to perform this and might be able to see a previously unknown population. 3 stars were produced by primordial matter after the Big Bang. Although scientists have a general understanding of how early stars form the elements necessary for life in modern technologies such as carbon, silicon and gold, one of the main research goals of the JWST is to determine when and how the first stars were born shortly after the Big Bang and how they generated the building blocks of the earliest galaxies. It is unclear how this happened at the time, but keeping the observatory in Chile was necessary to reduce unwanted background light and find faint objects in the farthest reaches of space. This was a crucial aspect of the observatory's construction. Observations of the first stars and galaxies will be just one of my many scientific endeavors carried out by the JWST. Astronomers from all over the world may apply for time at the observatory to conduct their studies. The results will provide insight into how stars and the systems of planets that orbit them emerge as a result of the collapse of dust and gas clouds because of infrared observations will allow Hubble to see straight into the stellar nurseries where stars and their planetary systems are being born. Exoplanets capacity. When the first concepts for the JWST were first put forth more than 20 years ago, there were no known planets out of our solar systems, but since then numerous new planets in our galaxy have been discovered by scientists. Exoplanets. Compared to Earth-based observations, the JWST's observation schedule will be dominated by these planets' atmospheres. Investigating chemistry, extraterrestrial atmospheres, and the low infrared background radiation is especially well suited to JWST's wavelength coverage. There are 2 possibilities when planets transit their parent star. Either we can examine light that has been divided down in wavelength to determine the makeup of the planet's atmosphere, or the star's light dims before and during the transit. A coronagraph, a piece of specialist equipment that shuts off the star's light so that the planet's atmosphere or surface may be seen directly, is another technique. This might demonstrate a planet's viability as a home for life, inspiring more study and the landing of tiny spacecraft there. The discovery of an Earth-like planet would be the ideal result, but this would require extremely favorable circumstances given the planet's rarity in the solar system neighborhood and obscurity in comparison to its parent star. It is most likely that JWST will use its equipment to study ice giants like Uranus and Neptune or gas giants like Jupiter and Saturn in our solar system. The solar system's planets all have orbits that are far closer to one another than Earth's, and they all have much hotter and more volatile atmospheres. JWST will be able to study both our solar system and planets beyond it. Since these asteroids would have bombarded the early Earth with water, the instrument's high sensitivity makes it ideal for studying comets and other ice objects in these outer solar systems. JWST will also be able to study the atmospheres and seasonal weather patterns of all the planets beyond the Sun and the orbit of Earth. Although exoplanets were considered science fiction when Hubble was first launched and they were one of the telescope's main goals, an ambitious game-changing telescope like JWST requires detailed planning and concepts for what will be found to justify the cost. There will be surprises that no one could predict. Looking forward to the findings that JWST will make, Dr. John Mather, the Chief Project Scientist for the James Webb Space Telescope, and Dr. George F. Smoot, a physicist at the University of California, shared the 2006 Nobel Prize in Physics for their work using the COBE satellite to measure the thermal radiation from the Big Bang. The Big Bang theory is straightforward, but it is also frequently misunderstood. For the uninitiated, Nobel laureate Dr. John Mather answers some frequently asked questions about the Big Bang and the importance of the James Webb Space Telescope in illuminating the earliest histories of the cosmos. To transmit the idea of a firecracker bursting in a certain time and place, a more realistic description of the expanding cosmos we observe than the Big Bang would be a cosmos that is infinitely growing. The expression Big Bang is apt because there is no such thing as a cosmic center. When did the universe begin? The Big Bang is not itself visible to us, but with that, what we are seeing about 380,000 years after the cosmos started expanding, 13.8 billion years ago, we can perceive the heat that was left over from early periods. Galaxies are moving away from each other rather than towards a central point, and the heat left over from early periods is equally distributed across the cosmos. It is unknown how far back in time the James Webb Telescope will be able to see. However, JWST will be able to view even further. This intense heat permeates the entire cosmos even now. In fact, it does. Satellites created by NASA and ISSA, include COBE, MAP and PLANT, allow us to study the universe's cosmic background radiation. There were only a few small fluctuations in the temperature throughout the cosmos at this time. For the most part, we don't know when or how the cosmos first formed stars and galaxies, which is the question we hope JWST can help us answer. After the Big Bang, we're interested in seeing the earliest objects to develop when the universe cooled down. This may be hundreds of millions of years later than the period COBE, WMAP and Planck were constructed to view. We believe the minuscule temperature fluctuations they saw were the gems from. Despite our best efforts, we simply do not know all the chemical elements other than hydrogen and helium were created by the earliest stars, and that they must have had an impact on the formation of other elements. Hubble can't detect the weak heat signals of these distant objects because they are too large and cold. The first stars to form after the Big Bang generated the chemical building blocks of life that have brought us to this point in time is something we are interested in learning more about. How incredible do you find this creation to be, and how long do you believe it will continue to be the best? Please leave a comment below. Remember to like and subscribe to this channel and click the bell symbol to be notified whenever we upload a new video.